using microservices. Wix is a web publishing platform. We have developer centers in Israel mostly, but also in Lithuania and now in Ukraine. But before we start about talking about all the technical stuff, I want to talk to you about dreams. Right now, this is probably one of my dreams, that would be the driveway for my house. But there are a lot of dreams, and we all want to do a lot of things. And the possibilities is endless. But other than the dreams, I had a specific dream like a year ago that I wanted to climb a big mountain. So I climbed, I think it was the biggest mountain in Africa. And after 5 days of trekking and going all the way, this is a picture from the top at like a minus 10 degrees. For you, maybe it's like summer, but but for me, it was very difficult, and my headache was exploding, and my head was exploding, and I wish I had another dream. But a dream that I can share probably with like the female and male engineers here is that I always want to be a developer. And if it's a dream, then I want to be a great developer, not just good developer. I want to be a great developer. And during my my career, I realized there are a couple of things that makes you great at what you do. One of them, and one of the values that we share in Wix, is that everybody has to be the owner of the service. We build it, we design it, we deploy it to production. We decide when it's deployed. There is no one that's going to stop us or tell us what to do. And on the flip side, if the service breaks at 2 a.m., you're the one who's getting the phone call, and you're the one who, and that actually happened for me a couple of times. I really try not to wake up early in the morning. Another thing is that as the developers, we're proud of what we do. It's not only just pieces of code and lines of code. We want it to be beautiful. We want it to have the best performance. And sometimes as a developer, or my developers will come to me and tell me like, oh, I want this service to hold like 1 million transactions. And I'm telling them like, wait, it's just opening up. Let's see. Let's first build it for a smaller amount. And if it succeeds, then we can do it later on. This is why we must be customer-driven. The need of the product is the need of our customers. And if the customers doesn't like it, then it won't grow. So we have to be aware and sometimes, hold ourselves back and not use the best technology, because in the end, the customers is what's important. And this is why it's important for us to be effective. It's important for us to deliver stuff to production as fast as possible. Because in the end, we all have our the development cycle, which includes developers and client personnel, and also sometimes a QA cycle or two. But in the end, the most important feedback is the feedback from the customers. If the customer wants the window to look like this, then it will look like he wants to. And if he doesn't want it to look like this, then we'll have to change it. So in an internet company, it's very, very important to deliver things fast. And this talk will talk about a little bit of how trying to make things a little bit faster. So you're starting a new service. How many people here have like a Monolith in the company? Yeah. And how many people are doing microservices? Okay, and some people didn't respond. So first of all, how many people like with microservices start at day one building a microservice? Okay, so you like this talk. Oh, just a second, this annoying thing. No, not now. So one of the things I noticed during my development as a development process is that with a monolith, a lot of things are very easier at first. There are no integration issues. Backward compatibility is less of a problem. It's actually faster to start with a monolith. And it's good, but monoliths are considered not like the new thing and considered bad. But It's because microservices are better for services which are more late in the stage of production. It's easier to monitor, it's easier to work about. Not a lot of people are touching the same code base. A lot of people on the same code base usually means a lot of fights, and you prefer to have like more islands of code where all the people who are vesting and investing in that specific piece of code knows exactly what's going on. And if it's too big, then it's very difficult for other people. So we know we want to start with a monolith, but we want to continue when the service is a little bit more stable to go to a microservice. So in this talk today, we'll discuss of how to build a monolith when microservices are in mind. That how do we build something that could be detached later on, and also when to detach it and what happens to the organization afterward. So let's try and build a detachable monolith. How are we going to do that? First of all, let's look at our current server. Maybe it's a new one, or maybe it's already existing. And the server contains, well, it contains web controllers, it contains our business logic, and also it contains DAOs and domain objects, and also, of course, contains all of the tests for the system. It tests everything, so we make sure we can deliver it safely to our customers. And we get a new feature request of what a feature request can be. A feature request can be a core service. Maybe our product people wants us to start sending emails, or maybe a system feature like we want an internal back office for the system to allow us to touch things that the user cannot. Or also some user feature like more landing pages. So how do we add it? Like we have our stores server, and let's say we want to add a back office to it. So the back office module, what will it contain? Well, basically the same thing that is in the current server: web handlers, DAO, persistency, domain object, and also tests. So first of all, we can add it as a different module. It's a different domain. Let's put it not in the same monolith. So now we have two modules. One of them is our new back office, and all of the other code is the current code that we have. But the first pitfall that we'll hit is that if the code sits in the same code base, we will start to depend on internal stuff on the other module. That would make it very hard for us to separate later on. So if, like, for example, like the first pitfall would be that our back office is actually touching like internal classes inside of the core module, and if you later on will want to take that module and deploy it somewhere else, it's going to be very difficult, because the more they know each other, the more it's going to be difficult to formulate an API later on. So what do we do? First of all, let's take the current server and refactor it. We'll create a new module. We'll call it core, or this is the current code. We'll put all the business logic and everything in it, and we'll add a new module. We'll call it the server module. That server module is just the wiring of stores of our store. It's going to contain, for example, we use it right now Jetty. So the starting of the service, creating of all of the objects, and all of the things that are just the composition layer that starts the server. We'll also include integration tests because we write the code, but we want to make sure that the server starts up. If we don't have integration code, we don't know that the whole system works together. And after we completed that stage, we'll try to break the dependency. How would you do it? Let's introduce a new module. We'll call it the API module. We'll take the interface from the core, put it inside of the API module, have the back office depend on the API, and this way there is no direct dependencies between the two things, between the core module and the back office module. Once we did that, we can remove the dependency between core and back office, and then we can have just the server knows all the modules, which is just a composition layer, and in the API, those are the interfaces. So now we can drop the dependency. But what happened if we're not only sending string? Let's say we're sending a domain object. What are we going to do about them? Are they API too? Well, of course they're API. Actually, domain objects are more complex to maintain later on. So if we're sharing a specific object, let's say, for example, back office needs to retrieve the user information from our stores. So it will retrieve probably, if we wrote it in code, we'll just return the whole object to the as a result, or maybe use like a lot of more information. But this will cause later on a lot. It's going to be difficult to maintain. So if we're oversharing the user object, later on we'll have to support it and support backward compatibility with it. So I suggest that even if you share domain objects, just share what you need. And this will allow us to later on to formulate an API better. And I don't know if you noticed, but once you have strict dependencies and stricter boundaries between the modules, it would make it easier. So in this sense, this is why I chose this quote: "Good fences make good neighbors." If the modules doesn't know each other, or at least not directly, and we control the exact amount of information that goes between them, it will help us later on to detach stuff. It also allows us to know exactly what back office needs from stores. It formulates an API a lot better. The second dependency, which is also other than domain dependency, is very, very difficult, is having the same services using the same database, using the same tables. If we want to able to detach stuff, we want each module or each domain to have its own database, own separate database, so it won't know each other. Why do we want to do that? Is because with a big table, we'll have multiple reads and writes to the same tables, and if it's across services, it's a big pain. Other than that, when they share the same database, then of course we're developers and we want to have it as fast as possible. So we'll create join between the tables. Those joins later on is going to be a very, very big problem, and I'll start to tackle those problems from the easier to the more difficult. The first one, let's consider reading and writing to a specific domain, just related to a specific module. So for example, if back office was using the same table as core, what we'll do is create a client which is also an API for us, and we'll communicate. Instead of using directly the database, just ask it. So now we're pulling the selects and everything, we're pulling it through the code now. So now it's an API. And once we did that, further on, even if they're sharing the same database, the same physical database, we can still later on fix it and extract the table. So this problem is a little bit simpler. But the biggest problem is that you join stuff. If you join between tables, afterward, it's going to be very, very difficult to write the code. So if someone tells you, like, I wanna extract this to external service, that's going to take a lot more code. So first of all, treat joins. Try to reduce the amount of joins. But if you did a join and you extract things, now you want to have the join done in the code. It's a server concern. It's no longer a database concern. And that would make it possible later on to split the databases. But performance, everybody's going to yell like, oh, it's not going to perform much as well. Oh, what happened here? Apparently there is a new version. I had to know it right now. I'm sorry. Just a second. So when we have, like, this is the way that we solve stuff in a performant way on our servers. As for example, first of all, you can always do things synchronous and in memory, retrieve data from one side, retrieve data from the other side, and join it in the code, even if it's across servers. But sometimes when things gets a little bit more, you need more and more performance, then you create your own local copy and update it like every 5 minutes. We actually have an open source that does that you can tell them like retrieve the database or retrieve all the data, pull it locally every 5 minutes. So that is also an easy solution and a very performing one. The last one is actually if you need a very eventually consistent data structure that you want it to be very fast, then you do build an event source system, and then the local copy is always updated. Well, it's updated until like a specific amount of time. So we can solve also the performance problem. Another final, I think the final persistency tip, this is I think the most important one, is that if you write a new service, try not to write it the same day to the database. The reason for that is because domain is changing a lot, at least, especially at first. If you have a product and then the product people say like, we want to have a title. So, okay, so you add a column with the title. But afterward they go like, okay, but we don't want the title. We want like short title and long title. So all of those iterations, if you have to go through system and update the database and maybe some backward and migrate the data, that would take you a lot of time. So I suggest just at first, do everything in memory. Don't worry, when you'll hit production, you will write it to a database. But at least until the domain gets stabler, write it in memory. And if the product people are playing with it, just load the data with some initial data. And then they play with it, play a little bit. The client people can integrate with it. Product people can look at it. UX people can look at it. And maybe they'll come to you and say like, okay, but every time the server restarts, all the data is gone and we're back to scratch. So what I do, even in that stage, I just write it to like a global location, to a file or something. Those iterations, especially when you have like a very new domain, every change like that usually takes a couple of like maybe hours, and if everything is in memory, it takes about minutes. So it's a very important performance tip or delivery tip, and it will save you a lot of time because migrating data is not fun. And again, when you get to a point where you see that the domain is stable, no more changes, no more. Not that there's not going to be domain changes in the future, but the amount of them is going to be a lot lower. So if you start with an in-memory, at least you can go to the stabler stage in a very short amount of time. And again, so we have like those modules. They all have their own database. They're all they're easy to split. So when do we split them? Because if we'll continue that, then we'll end up with a monolith, and we don't want to be there in the future. We want to be them, but they're only at the beginning of the product. So, so first of all, wait for a trigger. Usually, when things happen, this is when you wanna split the service outside. For example, if the scale grows big. This is one of the things that if you decide at day one that you want a microservice, then people will go like, okay, this service needs a lot of traffic and this service doesn't need a lot of traffic. But again, nobody knows if it will need another traffic. So if the scale goes up and you need to add more instances to it, this is this time that you want to extract that specific module and give it more servers. But if it doesn't, then no. Again, stability. If there is a specific module a specific service that gets to be more critical, or we decide to kill it or something, and we want to put it aside so it won't be so fragile because the current system is being developed, then we'll extract it. Also, sometimes people from the organization, I was doing a push notification service for my specific service, and then other teams wanted to say like, okay, we want to send also push notifications. So when they wanted it, and I said, okay, so I can't have them like touching my service and rely on my service, so I'll extract it to another microservice and have it use as a core service. And another thing which is not even related to code. You have a team member who's in charge of that email system or push notification system, and he goes to another team. He moves the responsibility for that service goes with the person to the other team. So we want to move the code to another server or to an external service just because a personnel is moving from one place to another. So there are triggers that would force us to break the monolith. But what happens if none of those happen? Well, if none of them happen, we should wait until it does, because sometimes we build products, not all of them will succeed. It's painful. It happens, but only if it succeeds, those things will require it. And if it doesn't, just keep it that way until they do. This will save you even in that stage. When you're a monolith, it's easier to look at and monitor. So we want to split. Now we have those modules. Server knows BO and core. BO just knows API, and core only knows API. How do we split them? Is it going to be difficult? If we build the thing stuff, we can just take our stores BO, the same module that we have. We'll call it now back office. We'll call it back office core because it's a new service, and we'll build it another server harness that starts everything up, and we'll add the integration test to it as well because we want to know that the server is up. So now we have a new server that serves only back office. It doesn't, but still we want it to communicate with the external service. So the step 2 would be that back office core needs to know how to talk to the store's core, to the other server. It needs to retrieve that information. And again, why is it? It's not difficult to implement right now because all we need to do is build implement this API instead of a local one to access a remote server, and it's very simple for us because now all of the API. We know the exact communication between those two servers. All we need to have is the remote store to implement this, to know which data is receiving from the API and implement it. Right now, we built at Wix an infrastructure that can actually allows you to send JSON RPC call very, very simply. But right now we're in the process of moving to gRPC, and in gRPC you actually have an IDL that if you formulate the API with it, it's even supporting like many different other languages. So those infrastructure exists, and they're very easy to use. So it's a shame not to use them. And so right now we extracted a monolith, and it shouldn't have taken us a lot of time. It was very, very simple. So, but once we extract a service and we are moving very fast, like our product people are asking something, and 3 days later it's in production. But you should remember that you're not the only one in a company. And if someone is using your service and is having difficulties with it, everybody's going to move slowly. You're as fast only as your slowest team. So we want to be faster as an organization. What do we do? What do I do when I extract a service and I'm given it? The first simple one is documentation. Everybody would say it. Documentation is this an example from a GitHub page. We have a quick run through what to import, what to do, and people can start up using the service. But it's not enough. Documentation is good, but it's getting stale. It's not being compiled. We want something more stricter. So what we build is, first of all, once we export a service, we build a module with a contract test that define exactly what it allows to send and what are the response that it gives, what is the request it gives, all the validation. Plus, we're building a test kit. A test kit is kind of a server or a very lean version of the server that implements the contract that the service provides. This way, another team that wants to use your service just starts in the test kit, and it can test against it, and it can do everything with it without even talking to your service. Plus, if you want to communicate back to them, if you want to break them because they're sending invalid data, you can do it in the tests, and the integration becomes a lot more simpler. So, and the last tip on this part is try to reduce the amount of integration code. And this is sometimes you have to work like 3 more days to reduce the number of lines from 5 to 4. It's worth it, because the more people, for other people using your service, if they can integrate with less lines of code, if it's easier for them, it's going to be simpler, and they can move on and not hassle you. Because sometimes, every time when people struggle, they come to your desk and they tell you something is broke, something is not working. You want them to do that by themselves and reduce the amount of support you have to give them. This is probably the part that makes it very difficult to supply those things, but it's worth every minute you invest in it. The last one is, because we're starting a lot of services and we keep extracting stuff, we need to pay attention to the things we do over and over again. To extract a service, for some people, it sounds like a very big task. But the more you do that, you realize that a lot of the things that you keep on doing over and over again, they're actually libraries and common areas and backbone. So if you notice those parts, like for example, in Wix, we have a big framework that supports authorization and database access and starting a service and a lot of types of tests, like embedded MySQL and embedded everything other that we use, embedded Kafka or whatever. This is part of where all of the team benefits from the work of everyone. So if you're doing a service and you were using Cassandra and you started a server in your tests that was easy to test against it, then you notice that it's something important, then you extract it. Also core libraries like push or email or a lot of user interaction, a lot of core services. If you notice those things and you extract it and you create proper services for them, all of the other teams can benefit from it and have simpler work. And with that, I would conclude. I'll just try to leave you with a few tips. Start a monolith, but keep in mind that it can be detachable. So pay attention to persistency, pay attention to the dependencies between the modules. Plus, split a monolith only when needed. Don't do it beforehand, because it's just a waste of work. It's a waste of time, more dashboards to look at. Even in Wix, we have I think 500 microservices. Still, you don't want the 501 if it's not needed. Only if it's needed, extract it. You're as fast as your slowest team. Invest in integration time. Invest in proper documentation. Invest in test kits that will allow other people to press on and not talk to you and have easier integrations. And in the end, build your backbone, but backbone is created if only people are paying attention to those common patterns. If they're not paying attention, and if everybody does the same thing, then you'll have a lot of people starting, like writing code to start a database, writing code to do a lot of things. You want to do one of those things once, and once it's done, you forget about it, and people can just write a few lines of code, and that's it. And with this, if anybody has any questions, I'll be happy to answer.
Thank you, Noam. Questions? Если кто-то не хочет по-английски, я могу перевести. All right. He made the best effort.
No. At first, thanks for your talk, and I want to ask you: do you think it's if you already have solid application that you see it's time to split it on microservices to microservices? Do you think it's really better to do it step by step, trying to solve all these difficulties with this process, or it's proper just to start parallel from scratch to build
to start
such system?
so you're asking if to start as a microservice would have been easier. But this is the exact thing. You don't know what a microservice is. Like for example, you might have a contact form feature, and people are using that contact form. And at first you think like it's gonna get a gajillion amount of traffic, but apparently it doesn't get there. So you just open up a new service, and it takes you some time, and it's harder to maintain. If you listen to those triggers, and by the way, there are more triggers that I didn't mention. Like for example, monitoring, it's much more easier in a monolith than in a microservice. Or even if you want to notice abnormal behavior. For example, if you have like a lot of services hosted in the same server, then it's hard to understand which requests are taking longer, depending on the monitoring tool. So sometimes that is also a reason to split it. But if you do it in day one, usually the reasons that you do it are not there yet. So you might just spend a lot of work just for doing nothing. So this design by trying it like step by step, will in the end will give the customer better solutions. It will also allow you to move faster instead of just starting it every time. Like even I think in Wix I can deploy a service, like build it, and it would take me less than an hour. We invested a lot of time to actually do that. But a lot of organization to start a new server, sometimes it comes to days. And those days, it's better off that you will invest those days in developing features and not starting up servers.
I think you can rephrase Donald Knuth about premature microservization is harmful.
Exactly.
So, next one.
Thank you.
Hello, thank you for your presentation. And I have one question, not about splitting the application, but you said about keep everything in memory, just for beginning. So, and the question is, we have different time to access data in memory or in database. Should we care about this when we start working in memory? Just not.
What is the difference again?
About time to access data. So,
time source. Okay.
Yeah. So should we care about this, or
remember that this is the days where the server starts. First of all, you can also deploy those, manage those time source changes the same way you do in the database. Because what you're saying, you're probably using the time from the server, the database server.
No, I think Alexei is mentioning the fact that if you do the in-memory storage, it's fast, it's blindly fast, and then you switch to the database like the week before production,
and then it gets slow.
It is actually fucking slow.
Yeah, and it becomes a lot of issues, maybe, because some people not care about this when they work with.
That's actually a good point. Then, but like I said, you will move to database as soon as the domain is stable. So. First of all, if you did that, if you write stuff in memory, you might be able to start to persist like even like 2 months before because you were ahead of time. I took this thing to an extreme because I actually wrote all of the persistency for a service with like, I think it had like 15 tables, and I did it a day before we deployed to production. And but I don't recommend it to anybody. I should have done it earlier, but I had like so many things to do. But if you need the time to check it, by the way, I don't think you'll notice it because in development stage, you don't check those things. You have like 5 people accessing the database. So even if it's slow, you won't notice it.
Okay.
It makes sense, but if it doesn't, then allocate some more time before you deploy it to check that performance and then fix it.
Okay, but question, maybe we can add some like thread sleeps when we use memories in memory.
You can also do that.
Okay,
yeah, that's an idea, but this is actually more related to like chaos engineering. If you wanna check what happens if the database is broken. But again, you can simulate all of it in the code.
Okay, thank you.
Great question.
Hi, thanks for speech. So, quick question from you to your experience. Talking about classical three-tier architecture, for instance, user interface, business logic, and some backend. What is favorite victim to be migrated?
A favorite what?
Victim. Who is the first? From your
not sure I
experience.
understand.
Okay.
A fasted one?
Okay, we have three tiers. User interface.
Okay.
For now, it's maybe quite complex. We have business logic layer, and we have backend. In most cases, database. So, from your experience, what is most favorite part of architecture to be migrated?
To migrate it
to microservices, yeah. From Monolith.
Actually, it's like I started thinking about lately about that we also consider like client code as microservice because each service has its own client code attached to it. So it's also being split. So which tier? I think all of them, because microservices, other than a code architecture, it also changes the organization. It allows more team to grow and move separately.
So you talk more about business transformation rather than both business transformation and culture of
it's
working.
Basically everywhere. That's what's funny because we think about like we're engineers, so we go like, okay, I'm my own microservice. But let me tell you like something. If you have a team that has a very strong developer and you add like 2 more strong developers, suddenly. First of all, they start to interfere with each other, and sometimes there's a lot of fights in the team. So by having microservices, you actually allow more people to grow. So this is a human resource thing that I know that you don't think about when you do that. Plus. The structure becomes to be like the organizational structure is going to be more low. You don't need a lot of management, but each team knows exactly what it does. So I think that everything is related to microservices.
Yeah, but if I can rephrase the original question, you have a monolith. It has UI code, database. Like you have a monolithic database, and you have, let's say, the monolithic business layer, which to your understanding would be the first layer to actually start splitting.
I would go with the backend.
Thank you.
Backend.
Noam, quick question about how you actually collect the telemetry to make decisions. So which tools, ideas?
Connect what to make decisions?
To build the telemetry to collect everything from your microservice to make decision. Is it good? What's people using? So which products are the services you are using?
I'm sorry, I got sidetracked.
Okay,
collect what? Information back?
So you have some the telemetry data, right?
Elementary?
Telemetry.
So the metrics, the telemetry.
Oh, the metrics.
Yeah.
Right.
So what are you using to collect them? Which you are using and some insight?
It's not actually related to the talk, but we're using metrics, using Graphite and Grafana. We had a couple of things. We also have errors. We're using New Relic, and for what was it? We also were using some startup called Anadot, but we're in the process of not using it anymore. And this is actually collected automatically from all of the services.
Okay.
One more?
Hello. First of all, thanks a lot for your presentation. And I'm wondering of your experience. What do you think? Which approach is better? To split monolithic application into as much microservices as possible, or vice versa?
No, I'm not suggesting to stitch it up, although it is possible. But like I said, it's not my favorable. It's what's needed, and if it's needed, then go ahead and extract them and have many microservices, but only if they're needed. This is the big question. I wouldn't start the day one. This is actually the whole topic of the presentation. Not do a premature microservice architecture just to do microservice architecture. Do a microservice architecture when it's needed, when the service demands it.
Thanks.
Anybody else? Any more questions? We have a little bit of time. Just while you're thinking, a quick poll. Has anybody actually gone through the opposite way of putting several microservices into the Monolith app? No? No hands? Have you done it? Well, let's keep it for the last part of the conference where we'll have the unconference. That will be a great topic for a great conversation with a lot of controversy. So, yeah, that's true. Any other questions? No? So let's thank Noam. That's a great talk. Thanks, everybody. Now we have time for lunch and see you.